Okay, so what I want to do before we go through the quadratic functions is just look at straight line functions first, which you're familiar with, because the concepts of the straight line functions actually follow through to the quadratic. So if you understand the straight lines and you're used to them, then you can kind of think, well, what do I do when I need to find the...
Nick, you just broke up.
Oh, okay. Well, I think what will happen is the video should have me not breaking up, but
Okay.
So what I was saying is the straight line functions, those the concepts that we use for the straight line functions, we use in quadratic functions. So the way you find your x-intercept and your y-intercept is very much the same idea that you make for the x-intercept, the y equal to 0, and the y-intercept x equal to 0. Okay, did I break up again?
No, understood.
Okay, so let's look at the normal straight line we know as y equals x, right? Which goes through the origin. So a key point is that this is the origin. So when we talk about the origin, and then here, we'll make this the x in green, and then the y in red. And so if you were to find the x and the y-intercept, they're both 0. So if I was to make x 0 here, y equals 0, would tell you, oh, okay, it goes through 0. But then if I was to make x y equal to 0, I'd say 0 here, and I'd say have x equal to 0. So if you make one of these 0, you can find the intercept. So we'll just quickly do that for straight lines, because I know that you know that already. But if we had a y equals x plus 1, basically we know that that shifts it up by 1. Let's just... Okay, and so there's a 1 there. And notice that this is a minus 1. And so if we were to find the x-intercept, our x-intercept, we make y equals 0. And so we'd have, we replace this y with a 0, and we have equals x plus 1. So the x is in green. X plus 1. And notice the 1 goes to the other side, becomes minus 1. And so that's why it actually shifts to the left. If we're looking in terms of the x, it actually goes backwards, even though it says a plus 1. And that's because x and 1 are on the same side. So I know that this might sound basic stuff because you know straight lines, but as I said, when we're dealing with quadratics, we do the same thing. And then obviously the y-intercept, we make x equal to 0. And so we would have y equals 0 plus 1. And so y equals 1. And that's there. So the idea of your intercepts is just making the one thing 0. So now let's look at your quadratic equation. So notice here we have an x to the 1. And so if it's x to the 1, we only have one intercept on this x-axis. And so what we're going to see now is when we have a y equals, let's make it x squared to begin with.
Nick, you keep breaking up quite often.
Okay.
Yeah.
I don't know if it doesn't say my internet is unstable, so I'm not sure if it's the internet on your side. But
my internet's fine here as well.
Every time I do, just ask me to repeat. So did you get all this stuff about your... I
got most of it.
Okay, so the idea that you haven't, but as I say, when you watch the video again, hopefully it won't be breaking up. But it's obviously important that you understand the first time, and then the videos just to kind of go through again. So you got that to find your x-intercept, you make y equals to 0, and your y-intercept, you make x equal to 0. That's the main thing we got to learn.
Okay.
And then the other thing is that that would then transfer to your quadratic equations. So I said yesterday, when you have y equals x squared, if you have 1 squared, that's 1. So if you were to make this x bit, or if you would have minus 1 squared, that would also give you 1, right? So this x, which we've been doing in green, the x, notice -1, they both come to 1. And so your y is always going to be a positive, because even if it was -2, that would come out to 4. Because -2 times -2 is 4. Were you able to hear that? Did that come out clearly? Are you there?
Yeah, sorry, I was just blowing my nose.
Oh, okay. Did I break up there, or was that okay?
No, I heard everything. Thank you.
Okay, so that is why this parabola, it goes upwards like this. And it's one thing to note is that it's always positive. Okay, so we have this, if this was -1 and this is 1, then this would be, the y's would be 1 and 1. If it was -2 and 2, the y is still going to be positive. So here would be 4 and 4. So this point would be 2 and 4, and this would be -2 and 4. Okay, so notice that we only have, at the moment, we only have one intercept, and I'll get to why, because it sort of crosses over here. So the first now key point about this shape of this graph, aside from the fact that we notice that it has the smiley face and is always positive, is to now remember that if you would ever to get a negative in front of the x squared, this would turn our 1s into -1 and -1. And so you actually get a sad face. And
so in other words, you're saying the negative would be before the brackets.
Yes, exactly. So in your SATs, if you're given like a multiple choice question and saying like which graph applies to the following equation, and you see a negative. So maybe there's 4 options, 2 are positive and 2 are negative.
Yeah.
And you're going, okay, well, I don't know, not, but I can guess. Well, at least you can narrow your guesses down to just 2, because you're going to pick the ones that are negative for if it's a sad face. So that's the number in front of the x squared. Notice it's the bit in front of the x squared, not the x. Okay. Now we're going to look at, so that is talking about the shape, and then the idea of your intercepts. Well, if I was to replace x with a 0, I'd have 0 squared, so I'd have y equals 0, and so we notice that it goes through the origin again. And if y was 0, well, x would have to be 0. So at the moment, it hasn't changed from this initial one, but then the next bit we're going to look at is when you have an x squared, as long as it has an x squared in that equation, and not an x cubed, because that would be a different thing. But if you had an x squared plus something, you're dealing with a parabola, you're dealing with a quadratic equation. So now let's look at the different forms that they might take, because this is obviously a common type of question in your SATs. Okay, cool. Okay, so we had y in red. Okay. So now we're going to look at, this has still got an x squared. So we are still dealing with a quadratic.
Parabola.
Yeah, parabola, sorry, parabola. So remember we had the idea that it would be
smiley face.
And let's say that we now wanted to find the x-intercepts of this function. So to find
when you make y,
that's perfect, good. Squared plus x. And now what you do is you have these two brackets. You have an x and an x, and it must be a 2 or minus a 2 and a 1. Now, when have you got your silver calculator yet?
No, he forgot it last night.
Okay, so when you get that, that's going to give you, you're going to put in. So, okay, so, all right, let me go back to the A, B, and C that I was talking about. So we have numbers in front of these that we consider A, B, and C in maths whenever we work it. So the general format of this is y equals something x squared plus something x plus something. So this would be, we'll do the A in, let's use pink. And so here our A is 1, right? So ghost 1, it's there, but we don't see it. Again, we have a ghost 1 in front of the x2. And so that is our B. Oops. Something x. So let's do that in yellow. So that's a 1 there. And then if there was no minus 2, so if it is x squared plus x, you just say that your C is 0. So if you don't see anything, or if you don't see an x, you just take that number to be 0. So with your x squared, that y equals x squared 1, there's no B and C, but you do still have to write them. So here it would be A equals 1, but then your B would be 0, and you would need to put this into your formulas. And so if you don't see anything, just remember that it is still there. So
would your C also equal 0?
Exactly. So here your C is actually now minus 2. So for this one, those would be your numbers. For here, we got A, B, and C. And so you could put, so when you have your silver calculator, you put A, B, and C into your calculator, it's going to give you the following answers. Well, let me just do this first. So I'm going to say a +2 and a -1 because it's more positive. And so to get the -2, that would be thing, but it's more positive. So the positive goes in front of the bigger number. Now your calculator is going to give you, because this, when we can say something times something is equal to 0, one of those somethings can be 0 because 100 times 0 will be 0. Now, 1,000,000 times 0. So either of these can be 0. So I can say 0 equals x minus 1 or 0 equals x plus 2. And what we notice is that the 1 goes to the other side and becomes positive. So x equals 1. And the other one,
x equals -2.
Yeah. And we usually just actually write it this way around, but I was just sort of showing you that that goes over there, becomes positive. So your calculator gives you the calculator gives you the answers. Now, if you would ask the brackets, so sometimes they ask you for the factors in a question. If they ask you for these brackets, you must just go backwards. Yeah. Okay. So this tells us that our x-intercepts are 1 and -2. So -2 and 1. And what it also tells us is our, if we wanted our y-intercept, we make x equal to 0, right?
Yeah.
What were we doing our y's, and we're doing the y in red. Back to the colors. Y equals, and our x was in green, so it was 0 squared plus 0 minus 2. I mean, the y-intercept's easiest to write it last because it's just that number always. As long as it's in this form. Okay. So we would know that it was -2. And so you could draw your parabola. So it would kind of be there's sort of a symmetry between these 2 points, and I'm going to do it in a different color. Orange. Not a very good process. It's a bit steep to draw nicely.
Yeah.
Because I don't like to see the V's looking so sharp. You know, students do this, and I kind of prefer this thing. But my points have trapped me into drawing badly. So this is the first thing now. So you asked yesterday, there were the 3 types, and they were like, which is the Y-intercept form? Well, we can see that this one, because it just directly tells you this Y-intercept, right, in red over here, this is the Y-intercept form.
Okay, so if they ask for the Y-intercept in the exam, then I'll literally just make X 0.
Exactly.
And then vice versa.
Yes, so even if it's, because sometimes it's written like this, right? X minus 2 squared plus 3. Now, if you just take the 3, that wouldn't be the Y-intercept, because when you times this out, you get some other numbers. So you'd put a 0 there, and then you get 4 plus 3, and you get 7. Right? But the reason I call this the Y-intercept form, though, or sometimes the standard form, but in SATs, it seems to, the Americans seem to call it the standard form, the Y-intercept form more often than standard form. But your standard form is this something x squared plus something x plus something. So that's the Y-intercept form. The reason being, it literally tells you directly the Y-intercept is minus 2. You know, you can just read it off. Whereas the X-intercepts took a bit more work.
Yeah.
Does that make sense? So that's the first one. Now, what we notice about this is it's got a turning point. And so we're going to now look at another form where you would just be told your turning point. So this x squared plus x minus 2. When you put this in your, when you want your turning point, I'm actually going to show you an easier way than completing the square, which is tricky, which is simply to remember to find the x value of the turning point. I simply put negative b over 2a. Did your girlfriend tell you that one?
No.
It's just negative b over 2a. Okay. And that will tell you the x value. So notice the turning point of this one, the first one, well, b, remember there's no b, so it'd just be 0. And we see the turning, it does actually turn on that axis. Let me repeat that. If this was 0, because of the b being 0, the answer to this question, because 0 is on the top, is always 0. And so, yes, it just turns on there. So,
okay, so it's actually not, I think I was just overthinking it the whole time.
Possibly, yeah. So let's just quickly do it for this one, right? So we've got the negative b. So remember, b here is 1. It's negative 1 over 2 times a, and a was also 1. And so this will work on any of them. And so you just literally just replace the b's and the a's. And you have negative a half. And that makes sense because negative a half is between 1 and minus 2. So we have negative a half here. So that would be the x value of this turning point. And then the y value, we can simply just substitute that half, negative half, into the equation, back into this equation. So to find the y value, we go x, we said, is negative a half. And so the y value of the turning point, when we substitute this in, will be then a quarter, minus a half, minus 2. And so we get minus 2 1/4, or minus 2.25. And that makes sense because I was struggling because this was minus 2 at intercept and it was just slightly lower where the turning point was. So minus 2.25. So it's slightly lower than the red point.
Yeah.
So the turning point is just, let's do the turning point in blue, dark blue. So the turning point is just below there, and it's this here. Okay, so the key thing to remember is now, so to find your x and y intercepts, you make y 0 and x 0. So that was the main bit. Then the next key bit is if you want the y-intercept, the turning point, just remember this formula here. So we want to learn that. And then the other important thing is that these come in there's three different ways to express this quadratic. We've done the first one. Now I'm going to show you the second one that they do, which is they'll give you the answer. They'll give you the turning point and they'll write it in this format. Now, I'm just going to write it out and then you'll see. So it'll be the plus, for this one, it will be plus a half. Minus 2.25. Okay, now if you see it in this format, it'll be sort of, it'll look like this. It'll be sort of x plus, and they'll often say p squared plus q, and they'll sometimes put an a here as well. So this a could be like a negative, would it be a negative if it was a sad face graph? So here we see the orange is a happy face graph, and notice that the half changes to minus a half. And that's the same reason when we go all the way back to when we found the x-intercept, you see the 1 went across and became minus 1. So whenever we're dealing with the x, it always seems to change sign. And that's because the x and the 1 are on the same side. And so the concept of straight line having the 1 on the other side, notice that x and a half are on the same side. So when the half, if it were to go over, would become minus a half. So that's why you have this here. So let's just color code that. So the one's in light blue, right? So this minus a half comes from this half. And then the 2.25 is just standard. That's it. You just literally copy paste it. So minus 2.25 goes here. Okay, so this is probably getting a little confusing. So what I want to do is just write out a sort of a few of these turning point formulas, and we can look at how the graph would look.
Okay.
So we've done the standard form, which is the ax squared plus bx plus c. Now let's look at the turning point format, which would be y equals something, and it will be x. And notice that it's minus p. And the reason we're putting that in minus p squared is because the x always seems to switch signs, whereas the q is kind of direct. So if it's a q, this is, and then the a is just because there often needs to be a form, a number in front, the x squared. Okay, so it's probably easier if we look at an actual example. So let's say that we had minus x plus 2 squared. equals 4. Okay, so the other one, this format only told us the y-intercept without doing any work, right?
Yeah.
So that's why they call it the y-intercept. Now this one only tells us the turning point without doing any work. So I'm only going to do the turning point. I'm not going to do the other stuff. Well, we can do the other stuff, but the main thing is that when you see this format, it's telling you the intercept, the turning point, one of the values, the y value is 4, and the x value is -2, -2. And so it literally tells you the turning point of this graph. So if I was to go on here, I'd say, right, there's a 4 here. Y is 4, beg your pardon, y is 4. So around there. And then, oh, not this side, not this side. And then the x is -2, so it'd actually be on that side.
I just wanted to ask because this question still looks pretty similar to the one before. So how do you know that looking for turning points, and how do you know if they're looking just for you to work out the quadratic?
You talk about it looks similar from this one.
Yeah.
So we haven't really dealt with the SAT questions. This could ask you like, what is the turning point? What is the y-intercept?
Okay, so they'll ask. Okay.
Yeah, but now if you were to have to work out the x-intercepts, you'd have to do the work, or you'd have to, and then the turning point, you'd have to do the work.
Okay.
It's like depending on the format of the equation is how much what work you have to do. So
okay.
When I highlighted this in red, it was because the y-intercept, you didn't have to do any work. But in order to find the x-intercept, you have to do a lot, right?
Yeah.
I'm going to show you another format after this one where we don't have to do work to find the x-intercept. So to do the work here to find the turning point, we have to use this -b/2a formula. Now here, we don't have to use the -b/2a formula. It gives us the turning point. It's almost like a code, right? It's a not so secret code that we just have to learn, where it's a -2, and so this would be the turning point. And so you would then, the graph would look something like, because we see that it's a negative, we know it's sad face, and it turns over there.
Is it -2 because you said the x plus 2 always switches sides?
Yes, yes.
Okay.
So that's why -p in a sense tells you, so I should say that it tells you that means that p and q are the turning points.
Okay.
So when you see this -p and p, the reason I said minus is because of the switching. And that's important to kind of keep remembering, is that the number in here switches.
Yeah.
The q is normal. So I'm gonna maybe just finish off this to show, well, if they gave you this format, how would you get the y-intercept? Well, as you say, you would make x equal to 0. So we could actually just do that, right? Negative, and we just say 0 plus 2 squared plus 4. Right? So what did we do there? We just replace the x with a 0 to find the y-intercept. And so this would end up being 2 squared, which is 4. We minus that, so to actually go through the origin, because -4 plus 4 is 0. So let's just erase this. So this will go.
The only reason it's -4 is because of the negative before the bracket, right?
Correct. Yes.
Okay.
Okay, and then if we wanted to find the x-intercepts, we would have to actually multiply this whole thing out. So we'd end up with y equals negative. And this would have to be x plus 2 x plus 2, because that's when you square something, you just times it by itself.
Yeah.
And so x times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. This would be another lesson if you didn't know what I'm doing here.
Yeah.
But we'd have negative x squared minus 4x minus 4 when we end up having this. And so this would give us our, oh, and then also we've got to pop this plus 4 on. Yeah.
Okay.
Yeah, because of the, I didn't pop.
Then it's just negative x squared negative 4x.
Yeah, exactly. And that's actually quite a nice one to deal with, because what we do is we simply just take out a negative x, and we have x plus 4. And this, so negative x equals 0, which means that x equals 0. And x plus 4 equals 0, which means x equals minus 4. And yeah, we get that. There we go. There's our 0. Let's do it in pink. So x equals, I'll keep going. So x equals 0 there. And x equals minus 4. So we know that that's value is minus 4.
I just want to ask Nick, where you wrote y equals negative bracket 0 plus 2 at the top. Yeah, there.
Yes.
How do I know when to just times the 2 in? So like we just said, it's 0 plus 4, and when do I know to put it into 2 brackets and multiply out?
Oh, so if you're keeping the x around, you have to, because it means that there's no easy way of doing it. Whereas this one, you don't have to do it, because, well, I kind of actually did, right? Even if you did it, you would. So if we were to change this, right? So 0 plus 2, let's say that I didn't skip a step. Well, 0 plus 2 is 2, which is 2 squared plus 4. And so essentially I'm doing 2 times 2 plus 4, which is still giving me the negative 4 plus 4. So I could do it that way. It just, when you have a 0, it quite nicely goes away. And so all you do
in other words,
2 squared.
In other words, when it's a number, you can do that, but when it's a letter, you have to work.
Exactly. So if you have like 3 plus 4 squared, just make it 7 squared.
Okay.
But because you could do this, right? And then you say 3 times 3 is 9, 3 times 4 is 12, 3 times 4 is 12, and 4 times 4 is 16. And you get 49, right? But it's, so that just shows you that, yes, it works to do this, but why do it when there's numbers? It makes sense to do them in the brackets first. Okay, so I want to do 2 more of these. We're not going to do the full thing. We just want to just ring fence this idea of this turning point formula. How it might sort of look. So you could have sort of negative 2 x plus 1 minus 9. Right? And again, don't worry about the minus 2. It's the turning point we're concerned with. So the turning point would be x equals minus 1 and y equals minus 9.
Yeah.
And so we'd go, okay, minus 1 would be the x, minus 9 would be here. And it's a sad face. And so it would kind of go like that. Now notice that this doesn't have any x-intercepts, and that is we're gonna deal with that just now. Y equals. Now let's do a happy face 1, 2. We'll make this plus 9.
So is this a different question altogether?
Yeah, so this is a different question. It's just sort of showing you this format here. So it's got to have the squared here, otherwise it's just a straight line.
Okay.
So the square is telling you quadratic. This is telling you the x value would be 2, not minus 2. So it'll be somewhere along here, 2. And then plus 9. And again, what I've done is it's a happy face, so it goes like this. Sorry.
Why do you draw it through the... Sorry, I do ask some stupid questions.
No,
but
not at all.
why do you draw it through the 9 and not like, how do I say it? Like last time you drew it through the -1 and -9, kind of.
So see, so this is 2 and 9. So here I drew it through the
origin.
over here.
Yeah.
Oh, so I'm only worried about the turning point.
Oh, okay.
The intercepts sort of come later. So it kind of, the turning point is where it starts, right? So it's the turning point is kind of your maximum. You see that it's another point, right? Here you have a maximum. Because it doesn't go any higher. So if you have a sad face, we have a maximum. Here,
Okay.
notice we have a maximum too, sad face. Here, it's a minimum. So that's actually, I'm glad you asked that, because you have this idea of a smiley face has a minimum. So if you're smiling, there's a minimum, right? It doesn't go lower than that. And then you kind of think of your smile going on forever. A sad face, yeah, you have a maximum. It goes down.
Okay.
So here we have a maximum. So the other point now, the reason I did these two values specifically is because I want to then look at your x-intercepts to notice that here we had 2 x-intercepts. When we just went through the origin, we had 1. And when we have a sad face, where the minute maximum is below the axis, it never actually touches the x-axis. And here it's a happy face and it's above. And so we're going to deal with that next. So we looked at the 3. So we did the standard form, which tells you your y-intercept straight away, and we have to do work to find the other stuff. The turning point tells us the turning point. We do work to find the other stuff. I didn't find the x-intercepts. What I would have to do is times it out. Oh, no, I did find them over there. And then now we're going to look at the second form, the third form, which is dealing with our x-intercepts. So it'll look like this. So what are we doing? We're doing A with in yellow. So your x-intercept form looks like this. And again, we'll say minus. And we'll call this, let's call this x, or do minus and minus. We'll say minus x1, and we'll call this minus x2, because there's usually 2 x-intercepts. So we actually got a taste of that over here at the beginning.
Yeah.
Over here, this is essentially in the x-intercept form. We put it in there in that form. And so sometimes it just gets given to you in that form. An example could be y equals, I'm going to just do the exact one we did. X minus 2, x plus 1. Okay, and this essentially is just telling us your x-intercepts, you have the x1 being 2, because it changes sign, and your x2 being -1. And so we know nothing about this if we just looked at it, other than we have a 2 and a -1 and a happy face, because it's a positive. And so because it would be a happy face, it would kind of look like that, and you would have to then do work to find the other stuff. So it's like if you get given this, you have to times it out to get it back. See, if you were given it in this format, you'd have to times it out to get it back into this format here that we started with. So it's just like, it depends what format they give it into, they give it to you, what work you have to do.
Okay.
So those are the 3 forms. So in your SATs, they're going to, you know, for the multiple choice questions, they're going to ask you various stuff. And so you can just, when you do your Khan Academy practice, you're going to be looking for something like this. And this will tell you your what?
Your Y.
This will tell you your, so I didn't do them in the order that I showed you them. This will tell you
your X-intercept, isn't it?
No, X-intercept would be this format, right?
Yes.
Yeah.
So that will either show your Y-intercept or your turning point.
Okay, so and then we'll do another one. Let me do them all 3 so you can, might be easier. +8. So these are the 3 different formats.
Okay.
Which one shows you your Y-intercept straight away?
The third one.
Excellent. Perfect, because we know that it's got that there. So it's a bit different to this one. What does this one tell you, this top one?
Turning point.
Yes, excellent. This is like I've just done 4 weeks of matric maths, you know, like, because they do it in grade 10, 11, they show you functions. So like,
yeah,
the fact that you're getting it is brilliant.
Thank you.
Because a lot of guys will be like, oh, I know that, but then it's probably because they've seen it before. But if you've never seen it before, it's complicated stuff. And then the minus, this +2 would go to -2.
Negative.
Yeah, good. And then this tells you, this final thing tells you your
X-intercept.
fantastic. So this will tell you your
so that would be X +2 and X
Yes.
-7.
good. 2 and -7. Good. Okay, that's perfect. I mean, if you've got all of that, that was my goal really, was for you to kind of get fully why these 3 formulas are different and how you can apply them now, hopefully, to those questions. So I'm going to stop the video and I'll upload it and send it.
Perfect. Thank you.